Hello everyone, my name is Semih. I'm a first year industrial engineering student at Bilkent University. Today, I will present my Physics 101 project. Let's get started. The objective of this project is to compare the system's elastic potential energy with the changing gravitational potential energy when the system reaches its equilibrium point. These are the masses of the objects that I'm going to use throughout the experiments. For part A, I measured gravitational and elastic potential energy of three different spring systems. For part B and C, I repeated this process with two different spring systems. Let's get started with part A. At first, I started my experiment by finding spring constant value by using relation between mg and k times x at equilibrium point. They are equal to each other at equilibrium point. Note that I neglected spring masses and take gravitational acceleration to be 9.8 throughout the whole experiment. When the system stops at equilibrium point, we can use this formula to find the value of spring constant. Note that I found delta x by comparing the distances between two wooden platforms. After that, I used delta x to calculate gravitational and elastic potential energies. The formula to find the change in gravitational potential energy is mg times delta x, and the formula for elastic potential energy is 1 over 2k times delta x squared. I found 2 and 3 parallel connected spring system spring constants by multiplying spring constant that I found with the first system, 2 and 3 respectively. These are the results of part A. At part B, I kept 3 parallel springs for both systems. This time, I changed the mass that I hang to the system. Since spring constant is the same for both systems, only thing changed is delta x. These are the results of the part B. For the last part, I connected two springs parallelly and serially, respectively. These are the formulas I used to find each system's net spring constant. Note that masses I hang to both systems are the same for this experiment. These are the results of part C. As we can see from data tables, error rate come up really high. They are all close to 50%. 50% error rate might seem high. However, theoretically expected error rate for this experiment is 50%. Here is the proof. The proof shows that, in ideal circumstances, ratio of elastic potential energy and changing gravitational potential energy is 1 to 2. The reason for my error rates to not come up exactly 50% is I performed this experiment in non-ideal conditions, and the springs that I use might slightly differ from each other. Whenever I release the mass, it will start to oscillate, and after some time, because of the friction force, it will slow down to equilibrium point. However, at some footages, I stop this wooden platform with my hand. The reason for that is I want to speed up the process. This will not affect the final results since I do the same thing as friction force does. Thanks for watching.